Hi everybody. In this lesson I want to show you how to solve a rational inequality. Now a rational inequality is a type of a nonlinear inequality, and if you've never solved a nonlinear inequality before, you may want to go back and look at some other videos I've made, some on quadratic inequalities and a polynomial inequality that explains some of the background for how we're going to solve this one, and that might make this lesson a little more understandable for you. Well, let's look at this. I'd like to solve x minus 2 over x plus 4 less than or equal to 0, solve it algebraically, and then we'll verify our solution graphically. Well, the most common mistake students make when they solve an inequality like this is they remember something about solving a rational equality, that you could multiply both sides by the common denominator. And that is just very tempting right here, because if I were to multiply both sides by x plus 4, the 0 times x plus 4 would just make that x plus 4 go away, and I would get that x minus 2 is less than or equal to 0. And then almost fast as lightning, I could say x is less than or equal to 2, and that seems like that would be a really easy way to solve that solution. And notice if you plug in a number like 0 that's less than or equal to 2, it even makes it true, right? You get negative 2 over 4 is negative a half, and that's less than or equal to 0. And so you might really be tempted to just leave your answer and say that the answer is x less than or equal to 2, but that would be wrong. Because notice that another number that's less than or equal to 2 is negative 5. And if I were to plug negative 5 up here, I'd get negative 5 minus 2 is negative 7. And negative 5 plus 4 is negative 1. And a negative 7 over negative 1 is 7. And 7 isn't less than or equal to 0. Okay? So all of that is to say that that is the absolute dead wrong way to solve these. You can't solve that by multiplying. And another way you might think of that is to remember that if you ever multiply both sides of an inequality by a negative number, you have to reverse the inequality. But notice when you multiply both sides by x plus 4, well, that would depend upon what x is. If x was a negative 5, then you really multiplied both sides by a negative number and you forgot to reverse the inequality. But if you multiply by, say, if x was 0, you'd be multiplying both sides by 4, and then it wouldn't be a problem. Okay? So the way we want to solve these is similar to the way we solved other nonlinear inequalities. We're going to use the factors from both the numerator and the denominator to determine the critical value. So I'm going to look at this numerator, and I know that x equals 2 makes it equal to 0. I'm also going to look at the denominator here, and I know x equals negative 4 makes the denominator 0. All right, so my critical values are x equals negative 2 and x equals negative 4. Now I'm going to make a little distinction between these two critical values. I'm going to call x equals negative 2 a good guy critical value, because that makes the numerator equal to 0, and that's actually good. If I have 0 in the numerator, 0 divided by anything is 0. But the denominator, if that's 0, that's bad, because that makes division by 0. So I'm going to call x equals negative 4 a bad guy critical point. And so when I come down here to write these, I'm going to locate these on a number line. So here's negative 4. And here's 2. I'm going to put an open circle around negative 4 and a closed circle around 2, just to remind myself that I don't really want x to equal negative 4, because that would make division by 0. Okay? So notice that these two critical points divide the number line into 3 intervals, from minus infinity to minus 4, from minus 4 to 2, and from 2 to infinity. Now I'm going to choose a test point from each of these intervals, like say negative 5 from this interval, and I could choose 0 from this one. That's an easy one to plug in usually. And let's plug 3 in out of this interval. Okay, so I want to look at these values. I want to look at negative 5 and 0 and 3, and I am going to want to plug them into this expression up here. Now if I plug negative 5 in up here, I'm going to get negative 5 minus 2 is negative 7. So that would give me negative 7 on the top. And negative 5 plus 4 is negative 1 on the bottom. And so that equals 7. In particular, it's a positive value. In fact, if you've watched my other lessons on nonlinear inequalities, really all I need to do is identify when I plug in negative 5 as I get something negative in the numerator and something negative in the denominator, and a negative divided by a negative is a positive. And that's really all I care about, is that it's positive and greater than 0, because positive means greater than 0. All right, so if I plug in 0, I'm going to get 0 minus 2. That's going to be negative 2 over 0 plus 4 is 4. So that's equal to negative a half. And again, I don't really care that it's specifically negative a half, only that it's negative. So if I were to plug in 0 here, I'd get something negative in the numerator, and 0 plus 4 is something positive in the denominator, and a negative number divided by a positive number is a negative number. Same thing, we'll do this when I plug in 3. I'm going to get 3 minus 2 is something positive in the numerator, and 3 plus 4 is something positive in the denominator. Positive divided by positive is something positive. All right, if I wanted exact value, I'd get 1 in the top. 3 minus 2 is 1. 3 plus 4 is 7. 1/7 is greater than 0. Okay, so now I want to know, where is the quotient of those two factors less than or equal to 0? Well, it's less than 0 where it's negative, and it's equal to 0 here at 2. Notice it's not equal to 0 at the other critical point, negative 4, because that makes division by 0. So my solution to this inequality, and I have to think of it in terms of these both the numerator and the denominator, this x minus 2 divided by this x plus 4 is going to be less than 0, or meaning negative, or equal to 0 here in this interval. That's going to be from minus 4 to 2, and I excluded minus 4 because that made division by 0, but I'm going to include 2 because that made it equal to 0. So this is my solution to this rational inequality. It's the interval from minus 4 to 2, including the point 2, but not minus 4. Now I can also verify my answer by graphing the inequality and the function on my calculator. So if I were to go here, and let's graph x minus 2 over x plus 4. And let me just graph that on my standard window here. See what we get. Looks something like that. And this is a difficult graph for students to understand when you're first learning about rational expressions. And that's why the algebraic method I've just went through is so important. But we can use this to check our work. Again, I want to know, where is this expression less than or equal to 0? And you can see it's less than or equal to 0 right here. There's an asymptote right over here at negative 4. Negative 4 makes division by 0, and that's what happens graphically as you get this big chasm in the graph. And so notice that your graph is less than 0 right here, and that corresponds to the points to the right of negative 4 up to this point right here at 2, and right at 2 it actually crosses the x-axis and goes above the x-axis. So the only place it's less than 0 is right here, starting at negative 4, but not including negative 4, because if you go a little bit on the other side of negative 4, you're actually up here. All right? And then it's a negative until you get to this point, negative 2, and at that point it's actually equal to 0, and so that's why I included this point right there. All right? And again, if I were to come over here, and instead of graphing just the function, if I was to graph the inequality, if I were to go ahead and put in the x minus 2 over x plus 4, and then graph less than or equal to 0, so let me go to the second test menu, and I'll put in here number 6, less than or equal to, and then 0. This is a relational operator, and this will tell me, it'll test where this expression on the left is less than or equal to 0. And if it's true, if any particular x value makes it true, it's going to graph the number 1. And if it's not true, it's going to graph the number 0. So when I graph that, it graphs the number one where it's true right here in this interval between -4 and 2. Now notice it didn't tell me, it's not going to tell me whether to include the -4 or to include the +2. I need my algebra to figure that out. But if you put those two graphs together, what we have here is you can see that this is illustrating where the graph is less than or equal to 0. So in terms of this graph that we did, I wanted to find where this graph is below, that would be less than, or on, that would be the equal to the x-axis, because the x-axis is the same as 0.